Hello and welcome back to Mastering C++ 20 Features. In the last few lectures, we looked at how to create a simple coroutine that could be suspended and be resumed from the caller of the coroutine. Our coroutine was quite simple and naive in the sense that we could not perform useful computation. All it did was printed some std cout statements. Now we would like to create a more complex coroutine from which we could access the data when the coroutine is suspended, and maybe also pass around the data to the coroutine when the coroutine is suspended, and that could be later used for computation inside the coroutine when it resumes. So let's look at the highlight of the next few lectures. In the next few lectures, we would incrementally understand how to create a coroutine that does all of the below. Access the data when the coroutine is suspended in the caller, modify the coroutine's data in its suspended state from within the caller or within the coroutine itself, and perform synchronous or asynchronous calls during the suspension or resumption of the coroutine. In this lecture, we would look at how to access coroutine's data when the coroutine is suspended from the caller. Coroutine could have its data packed in its promise type, and the promise type is tied to the execution of the coroutine, and this could be accessed in the std coroutine handle. Let's look at the documentation of std coroutine handle on how to do this. Here's the CPP reference page on std coroutine handle, and the std coroutine handle provides, apart from other methods, a method called promise, which allows us to access the promise data of the coroutine. If we look at the reference page of the promise method, tells that it obtains a reference to the promise object, which means that on different accesses, we get the access to the same promise, which is tied to the execution of a particular coroutine, and that this function is not provided for the specialization with empty template parameters in the std coroutine handle. This is quite important for us because in the last few lectures, we looked at std coroutine handle with an empty template parameter. Okay, let's look at how to do all of this in the code. Here I have the coroutine called data access coro, which uses the same return object as from the previous lecture, and the body of the coroutine is also same as from the previous lecture. The coroutine is called in a method called caller, which returns a value double, and the coroutine is resumed until it finishes execution via the coroutine's handle resume or the overloaded bracket operator. We would aim to return a double value from the coroutine's promise type. So let's go ahead and insert a private attribute of type double. Private, let's call it value. Assign it the value of pi. And while we are at it, let's provide a getter method. And also let's provide a setter method. All right. And the second important point was to access the promise method inside the caller of the coroutine like this. Let's call it auto promise for now. Prom handle.promise. We have to ensure that the coroutine handle in the return object has the correct template specialization. In this case, we need to use the primary template for the coroutine handle. So this could be done by providing the template specialization promise type. So promise type here within the attribute, within the constructor. Should not forget the implicit conversion operator, promise type. And here, temporary object that we materialize, promise type. Here, this was already done. Here, I wanted to mention that the promise type outside the coroutine could not be accessed directly because it is the part of the return object. So we have to scope it correctly. Similarly, the auto here should also have a concrete type. It is deduced by compiler if we don't provide it, but just for your information, it is also return object promise type. This is the type of promise. Let's try to compile this once more. And now to get the value here, Okay, let's make it more readable by not using the uniform initialization. Let's say from dot get value. And let's try to use it here. All right, let's try to run it. And here we go. We see the value of pi that was returned when the coroutine was suspended after the first call. Here, after the first call, the coroutine got suspended and we access the value. Let's try to modify this as well when the coroutine is suspended. Let's provide int I, initialize it with 1, and here we call from dot set value. We have to cast it correctly to double because this is any static cast double I, let's say plus plus I, and then the coroutine should have the final value in the end. It should be, let's see what it is. Here we go. So this value was modified when the coroutine was suspended at this point. And then finally we accessed it also. So in this lecture, we saw how to access a coroutine data that could be packed within its promise type in the caller of the coroutine, and then also how to modify it in the caller of the coroutine when the coroutine is suspended. This will be used later, and we will use this structure and create more complicated coroutine that could do more complex tasks in the upcoming lectures. I hope you enjoyed learning more about coroutines. See you in the next lecture. Thank you.